Body movements. Have you ever wondered how various types of movements such as breathing, blinking of eyes, rotation of neck, etc. takes place? Notice the following type of body movements in your body when you are writing in your notebook, you turn about and look at your friends, you go to your friend's house to get something, you walk, run, skip, or jump. In the first two cases, different parts of your body move while you remain at the same place. We use the term movement for all such cases in which only a part of your body moves. Examples of such movements include movement of heart muscles, movement of blood, movement of lungs, and alimentary canal, etc. In the next two cases, the entire body moves from one place to another. We use the term locomotion when the entire body of an organism shifts or moves from one place to another. Walking, running, flying, jumping, crawling, swimming, and slither are few of the ways in which animals move from one place to another. Human body and its movements. Let us try to do some of the many movements which our body is capable of doing. You can see the circular movement of your shoulder whenever you try to bowl a cricket ball. You can see the bending movement of your leg at the knee and arm at the elbow. You can see the rotational movement of your leg at hip. You can see the stretching movement of your arm and legs sideways. Now, try to bend your arm to touch your shoulder with your fingers. Which part of your arm did you bend? Straighten your arm and try to bend it downwards. Are you able to do it? Try to move the various parts of your body. Have you ever wondered why we are able to move a few parts of our body easily in various directions and some only in one direction? Similarly, we are unable to move some body parts at all. Let us try to find out such body parts in our body. Joints. What exactly is joined together at these joints? Press your fingers against the top of your head, face, neck, nose, ear, back of the shoulder, hands and legs, including the fingers and toes. Do you get a feel of something hard pressing against your fingers? The hard structures are the bones. So many bones. Bones cannot be bent. So, how do we bend our elbow? It is not one long bone from the upper arm to our wrist. It is different bones joined together at the elbow. Similarly, there are many bones present in each part of the body. We can bend or move our body only at those points where bones meet. Thus, the point at which two bones meet is called a joint. The movement of our complete body is possible because of these joints. Bones are held together at joints by strong cords called ligaments. These ligaments are strong bands or cords of tissue that join bones or keep organs in place. In addition to this, there are tendons which attach muscles to the bones. There are different types of joints in our body to help us carry out different movements and activities. Let us learn about some of them. Ball and socket joints. In these type of joints, the rounded end of one bone fits into the hollow space of the other bone. Such a kind of joint allows movements in all directions. It is the most movable of all joints, example, the joint between the upper arm and the shoulder, the thigh and the hip. Pivotal joint. The joint where our neck joins the head is a pivotal joint. The skull is joined to the backbone like a ball on a stick. This type of joint allows movement in many planes, that is, it allows us to bend our head forward and backward and turn the head to our right and left. In a pivotal joint, a cylindrical bone rotates in a ring. Hinge joints. Open and close a door a few times. Observe the hinges of the door carefully. They allow the door to move back and forth. Hinge joints allow movement only in one plane, like a door hinge, and not more than 180 degrees. Example, the fingers, the knee, the elbow. Our wrist is a double hinge joint. Fixed joints. There are some bones in our head that are joined together at some joints. The bones cannot move at these joints. Such joints are called fixed or immovable joints. Example, joints in the skull, cranium. When you open your mouth wide, you can move your lower jaw away from your head. Now, try to move your upper jaw. There is a joint between the upper jaw and the rest of the head, which is a fixed joint. In an immovable joint, the bones are held tightly together. The dome of the skull, cranium, is a box made of bony plates. The plates of bone fit together something like the pieces of a jigsaw puzzle. The plates must be immovable to protect the brain inside. Partially movable joints. These joints allow partial movement, as can be seen in the case of vertebral column, where one vertebra meets another. Gliding joints. These joints allow only a limited amount of movement, which is also due to the sliding nature of cartilages. In these movements, the two bones slide over each other. These movements can be seen in the backbone, ankle, and wrist. If you wanted to make a doll, what will you make first? Perhaps a framework to give the doll shape before making its outer structure. All the bones in our body also make a framework to give a shape to our body. This framework is called the skeleton. Our skeleton is made up of many pieces of bones and cartilages. The bone is hard. Cartilages are comparatively soft and elastic. Like the hard steel frame of a bridge or a building, the skeletal system gives support to the body. It protects the inner delicate organs. Together with the muscles, it gives the body its shape. We can have some idea about the shape and number of bones in some parts of our body by feeling them. One way we could know this shape better would be to look at X-ray images of the human body. Sometimes when we are hurt or have an accident, doctors use these X-ray images to find out about any possible injuries that might have happened to the bones. The X-ray shows the shapes of the bones in our body. Rib cage. The chest is a cone-shaped cage. It encloses the heart and the lungs. At the back are the vertebrae. There are 12 pairs of ribs which start from these vertebrae and curve around the front of the chest. 10 of these ribs are also attached by cartilage to the breastbone at the front. 2 ribs are free. The ribs are joined in such a way that they allow the required movement of the chest during breathing. Backbone. The backbone or the vertebral column extends from the base of the skull to the hip. It is also known as spine. This backbone and the strong back muscles help us to stand erect. The backbone is made up of 33 separate bones called vertebrae, plural for vertebra. These vertebrae are ring-like and are joined end to end. The first 24 are joined serially, be elastic, like cartilage. Thus, it forms a hollow bony tube-like structure through which the main nerve cord or spinal cord passes. The last 9 vertebrae are joined together and do not move. The structure on which our body rests is made of pelvic bones. They enclose the portion of your body below the stomach. This is the part you sit on. Skull. The skull is made of many bones joined together. It encloses and protects a very important part of your body, the brain. The soft part of our skeleton can be bent easily. These soft parts are not as hard as the bones and are called cartilage. You can feel about this part in your earlobes. The cartilage is also found in the various joints of the body. We have seen that our skeleton is made up of many bones, joints, and cartilage. You could see, bend, and move many of them. Movement of bones. Make a fist with one hand, bend your arm at the elbow and touch your shoulder with the thumb. Do you see any change in your upper arm? Touch it with the other hand. Do you feel a swollen region inside your upper arm? This is an upper arm muscle. The muscle bulged due to the contraction. It became smaller in length. Now bring your arm back to its normal position. What happened to the muscle? Is it still contracted? You can observe similar contractions of muscles in your leg when you walk or run. When contracted, the muscle becomes shorter, stiffer, and thicker. It pulls the bone. Muscles work in pairs. When one of them contracts, the bone is pulled in that direction. The other muscle of the pair relaxes. To move the bone in the opposite direction, the relaxed muscle contracts to pull the bone towards its original position, while the first relaxes. A muscle can only pull. It cannot push. Thus, 2 muscles have to work together to move a bone. Working of muscles. The muscles at a joint work in pairs. One muscle makes the joint bend, while the other makes it straighten. The biceps muscle is attached to the shoulder blade at one end and to the radius bone of the forearm at the other end. So when it contracts, it pulls both the bones, bringing them closer together, causing bending of the arm at the elbow. This is called flexing of arm, and hence biceps is called a flexor muscle. Now to straighten the arm, biceps muscle relax. Muscles cannot push your arm back again. Therefore, to straighten the arm, triceps muscles contracts. This movement is called extending of an arm, and hence triceps is called extensor muscle. Thus, with proper coordination, both muscles can make the bones move in either of the direction. Movement in animals. The earthworm has a large number of tiny bristles, hair-like structure called setae, projecting out. These bristles are connected with muscles at their bases. The bristles help to get a good grip on the ground. The earthworm uses these bristles for movement. These bristles are made up of chitin, a type of protein. The earthworm actually eats its way through the soil. Its body then throws away the undigested part of the material that it eats. This activity of an earthworm makes the soil more useful for plants. Cockroach. Cockroaches are a common sight in our houses during the summer months. They are mostly found in dark, moist and warm places. Cockroaches walk and climb as well as fly in the air. They have 3 pairs of legs. These help in walking. The body is covered with a hard outer skeleton. This outer skeleton is made of different units joined together, and that permits movement. There are 2 pairs of wings attached to the breast. The cockroaches have distinct muscles. Those near the legs move the legs for walking. The breast muscles move the wings when the cockroach flies. Birds. Birds fly in the air and walk on the ground. Some birds, like ducks and swans, also swim in water. The birds can fly because their bodies, streamline-shaped, are well suited for flying. Their bones are hollow and light. The bones of the hind limbs are typically for walking and perching. The bony part of the forelimbs are modified as wings. The shoulder bones are strong. The breast bones are modified to hold muscles of flight which are used to move the wings up and down. The lungs have air sacs which not only makes the body light and buoyant but also increases the oxygen supply when flying. These air sacs help in double breathing as the air crosses the lungs twice, both during breathing in and breathing out. The wings and tail in birds are reinforced with various types of feathers, which provides an extended surface. This extended surface allows the wings to develop enough life to completely overpower the downward pull of gravity. The shape of the wings is such that air passes with greater speed from its upper surface than the lower surface. This creates a high air pressure below the wings, which causes lifting up of the wings, and as a result of this, these birds soar high up in the sky. Fish. Head and tail of the fish are smaller than the middle portion of the body. That is, the body tapers at both ends. This type of body shape is called streamlined. The shape is such that water can flow around it easily and allow the fish to move in water. The fish has got various types of fins on the body which help in swimming. The skeleton of the fish is covered with strong muscles. During swimming, muscles make the front part of the body curve to one side and the tail part swings towards the opposite side. The fish forms a curve. Then, quickly, the body and tail curve to the other side. This makes a jerk and pushes the body forward. A series of such jerks make the fish swim ahead. This is helped by the fins of the tail. Thus, we find that fish swims by moving body and tail from side to side. Fish also have other fins on their body which mainly help to keep the balance of the body and to keep direction while swimming. How do snakes move? The snake's long and slender body has more ribs and vertebrae than do other backboned animals. The snake is therefore very flexible, which is more advantageous during locomotion. Snakes have a long backbone. They have many thin muscles. They are connected to each other even though they are far from one another. They also interconnect the backbone, ribs, and skin. The snake's body curves into many loops. Each loop of the snake gives it a forward push by pressing against the ground. Since its long body makes many loops and each loop gives it this push, the snake moves forward very fast and not in a straight line.